All right. So I just wanted to thank everyone for the 100 subscribers. It's just it's been a great the channel which I'm currently running on is I think 1 year old, and we finally hit 100 subscribers. And on my previous videos, I was mentioning I wanted to that I promised when we hit 100 subscribers, we are going to make Pong live from scratch. Then at my one of my latest videos, I was saying, let's ramp it up a bit and do it in a language that I normally never use, because normally I always write in C#. So, and then I thought, let's do it in C in the way that Ray from Raylib likes. So the plan is that I'm going to use this Raylib quick start, because you don't want to see to do completely from scratch. I thought that's going to be a bit overkill. So let's just, but it's still a bit from scratch, right? So let's check this one out. It's git clone, yes. Is this, I don't think this is the correct link. No, that's not the correct link. We're already doing a great start. Let's do it like this, and then Pong live. There you go. All right. I must say that I already prepared it. I did already play around with it a bit, so that you're not going to see me struggle to set this up, because that will be a bit of a boring setup. I prefer that you see me struggle with the actual implementation. So let's, I think it was gmake. Yes. All right. By the way, I'm also going to use Sea Lion, because I have the full JetBrains suite, and I am very common in their dev environments. So I thought, let's do it in an existing environment. Let's see, repos, select folder. Yes, should be fine. Very good. All right, very good. Let's see if we can run this. Oh yeah. First I need to set up the correct binary. Of course. No, it's in build. No. Oh wait, I first need to build it, you idiot. That's because it needs to build Raylib and all the other stuff as well. Otherwise I don't have the binary. There you go. Should be fine. Yes, we have a binary. Perfect. Apply, run. Let's see. And there we go. We have a working starting point, even with a bunny. Ooh. Yeah, that's actually one thing that is actually kind of nice in this template, that it's already set up in such a way that the resources are automatically get loaded in. Because one thing that I personally really want to learn, that I really like to do, is adding the C logo as the actual ball, instead of just a round shape. I thought that will be will be a bit more interesting, right? All right. There we go. Let me make this a bit bigger. There we go. Then we have more than enough room to work with. Let's also, why can I zoom in. All right, now it should be fine. All right. So we have the texture and we have the rabbit, but we are not going to use that. Well, we can reuse it, but let's load in the prepared texture. So I have here an my, yes, it is a bit stretched, but that's because I really want to have it in the same width and the same height. So it's 640 by 640. So that's the reason why it's looking a bit stretched. Let's drag that one in here. What do you want to refactor? Of course. Okay. Also, I prepared here the cheat sheet, so we can quickly look up all the functions that we want to use. Which makes our lives, because this is basically all the documentation that you need for Raylib. That will be make it a bit easier. So let's first see if we can replace the bunny with the C logo. I know that pictures are not the most important. There we go. Yay, we have the C logo. Now you have definitely proof that I'm writing in C. We're already in a great start, guys. All right. But we are going to make Pong. What do we need? We need to have the something like an struct, and then that's something, I think it's, you are writing it in C as like this. So let's make a pedal, and then we want to use a rectangle. And the reason why I want to use a rectangle is that because in the cheat sheet they have also for things for doing collision checking, which makes it a bit easier. So this is the what are we going to call it? We're going to call it the bounce. Should be fine. And we are also at the same time using this as the position. Should be fine. And also that we don't have to type every time that it's a struct, which is kind of strange in C, but is it not the official C logo? It's clipped. So you need to write it at the end. Okay, thanks. That's the, but wait, what's then the official C logo? Okay, this is already there is no official logo. Is that what you're saying? This is already saying that I am not that experienced with in C. So yeah, that's but anyway, we also need to have there's ANSI C1 with a weird blue color. Wait, yeah, this is going to take additional time, but I don't care. Let's see the C logo. ANSI. Mm, interesting. Anyway, let's continue. Let's make the, we also need to have the, oh wait, this is by the way not the pedal, this is the ball. And this is going to be the pedal. And And at the same time, we are going to use this as the score. I think that will be fine. The ball and the pedal, and then we can use this at the same time for the rendering. Then, oh, actually, funny enough, we are still using the rabbit as the. This is the ball texture. There you go. And somehow let's first assign the actual pedal. And in the pedal bounce, this is okay. If I'm doing something strange or weird, then please let me know. But like I already mentioned, I am coming from, I'm mostly writing in C#, so we are using a boundary of 800 by 600, and we want to start, and again, I am confusing with the, oh, wait, yes, and we want to have the pedal. Then we have the ball and the pedal. Which is starting from 400, and I want to have it in the center, so it's 400 by 300. Yes. Minus 32, because it's then and yet again I am using, this is the ball, not the pedal. I'm still rotating it around. All right, width is 32, no, 64. Let's see how big this is going to be. This is probably going to be too big, but all right. Draw texture, and then we want to have it on the ball.bounce.x, and we want to have it. What is it complaining about? Oh, because it's in a conversion. Okay, that's fine. Ball.bounce I. Okay, there you go. Is this working fine? Or okay, so the ball is perfectly in the middle, so that part is then fixed. Perfect. We have a ball, guys. Woohoo! Don't take this strange. All right, then we also want to assign the. Do we want to make it as an array? I think we want to do that. So that means that we want to have the pedal as an pedal with a pointer, and let's also do a const int total pedals, not 6. That's going to be too much. All right, we have the pedal, and it's going to be pedal, and we want to do an RL colloc to allocate, and then we want to have total pedals with the size of course, with the pedal itself. There you go. And what's... Oh. All right. And also, we want to make sure that we are cleaning it up. RL3 pedal. There you go. We don't want to have any memory leaks, right? All right. So now we have the pedals assigned, and we should have enough with the bounce and the score. Yes. So that means that we can do an... we also need to set the values, of course. So let me think. There you go. It's not going to be the most prettiest code because, yeah, well, the I need to be able to finish this within reasonable time. Okay, the first pedal we want to have it at I think 16 or something. Then we want to start at because the height is 300. Then let's make the pedal like 128. So that means that we need to, and the width is let's make it 16, and the pedal height is not 100. There you go. That will be the first one. And of course, we want to set the score to 0. Otherwise, it will not be fair. And also, I don't know if we're going to be surprised with some garbage values in there. I don't know if that's the case. By the way, if I am talking nonsense, please let me know. Then please correct me on that part. So we are working with a width of 800, and maybe I should have this as more as a variable, but let's keep it simple for now. The pedal is 16, and we have an offset of 16, so that means that we are minus 32, so that means that it will be on the right side. So we have it on the left side, and we have a pedal on the left side and the right side. Should be good. And then we can make an... Hey, Lily. Dat is een binnenwel. I've been... this time I'm not writing in C#, so maybe you can now easier follow along with C, because you did write in C, right? Let's see. There was something that you can draw and draw. There you go. Oh, this cheat sheet is amazing from Ray. It's draw rectangle. Draw rectangle rect. Perfect. That's the one that I want. Then I can just pass in directly the values. Then it will be pedal e dot bounce, and we want to make it right. I still write a C. Oh boy, then you this will be then a comedy show for you, because I'm not really used to C. The only time that I'm actually writing C is then when I am writing in how do you call it, in Arduino. But yeah, it's not really comparable what I'm doing here, because then there are also a lot of additional functions in Arduino, which really helps a lot. But luckily, I must say that the C language is very simplistic in that regard. So remembering most of the stuff is not that hard. Comparing, for example, with C Sharp, where you have it. I mean, if I'm going to compare it, and I'm now probably not going to call make any favorites, but it's basically going from a large toolbox with a lot of stuff and already a lot of things done for you, to that you only left with a wrench, and then you need to be able to fix the car. But at least everyone knows how to use the wrench. That's also something I can definitely tell, if that makes any sense. All right, we have. Yes! Woohoo! We have two pedals, and we have the ball in the not official C logo. Very cool. Okay. Next up, let's. I'm first going to make sure that everything can draw correctly. I think that makes it also a little bit easier with the debugging part. So we want to have the score, and that means do I want to do that manually? I think so. Yeah, let's do the let's not overcomplicate things here. Let's do the score. Oh, this is going to be interesting. I don't know how the casting will be from a chart to thing, but should be fine, I think. Okay. One way to find out. Pedal dot 0 dot score, yes, and now it's going to whine about that I am doing an expression of type integer implicitly converted to the pointer type const char. Will that be correct? Oh, we can test, and also make it a bit bigger. That will be fine. All right, let's set the offset from the height somewhere here, and then let's put the position to somewhere in the. I try to be it to set it a little bit in the middle. Should be fine. And then we have also the second pedal, which should be on the other side. All right. To properly test this, let's put some random values in here, like 8 and 7 or 5 or something. And then we're just going to use the Raylib font for now. No. We have the first crash. What's happened? Did I make an oopsie somewhere? I think so. Let's see if this is the problem. Yes. So this is the first small challenge. How to convert something to an from a string to an int. If you guys have any suggestions, please let me know. Do they have something like a helper for it? Measure text, draw text. Otherwise, I'm going to look it up. Convert C, convert int to char. In C. Okay. Like a pop developer zoeking it up in the just assign the int to a char character. Ah. Okay, that's fine. So char score 1 is be careful, int and char are different sizes. Thank you. Those are indeed probably the reasons why it did crash. So let me see if there are some examples for it. Raylib examples. Show frames per second. Right. You have something. Be careful. Okay. Dot text while running in a browser. Last is int. Angle is. Ah, wait. You have text format. I see. Is this something from Raylib? Text format? No. Current angle in degrees. Is this something that it's a float? But I heard it was a const chart pointer. No, that's correct. It's an it's accepting an. Let me show to you. In here, in the draw text, you have an const char and then indeed a chart pointer, and then and basically I want to convert it from an integer to a text. So, hey, hello, Jeremy. So indeed, I want to convert it somehow to a char, but if I am doing it directly, it's going to crash. So, and I think if I'm doing it directly to a char, then yeah, then I'm probably just going to convert it. But for some reason, it's doing it here with a text format in the Raylib examples. And should be text find index, text.trim. All right. A char is not a char pointer. No, that's correct. The point is that the basically we have it accepting like this. But yeah, then I am just making a new variable, which is fine. But for some reason, we need to do something like text conversion of text format. Text format. There you go. Okay. Text format. Which okay. But then this is not correct. Yeah, that's also something that is a bit of a surprising. And in the Arduino library, they made a special struct to make it for people easier to use strings. That's something that I definitely can remember. But I do see that they are using printf here to convert it. So maybe that's a way. Now the string contains an integer as characters. We can try. Maybe creating a char array and then converting the integer for its ASCII values might work. Ah, yeah. That's the same thing that's it's mentioning here indeed. Let's try that. Let's do something like 2. But wait. Can we not just use a pointer? Don't forget to add null bit at the end of the array. That's a good point. Score 1. And then we have the pedal 1 score. Then this is what's this? Might not be initialized. Let's do it like score 2 is wait. Is it really suggesting it like this? Is this going to work? Wait. Let me try this. All right. Well, we at least have our first struggle. Converting something to a string. No. No. And indeed, you're right, completely right. Then we need to use a char score 1. And then let's do it like this. And then we need to use this for some reason. And let's support it until 2 now. And then we have score 1 with the pedal score. And in here, we're doing the same thing. Maybe it's nicer if we're going to make it as a function, but for now, let's keep it simple. And of course, I want to have it on the 0 and 2. All right. What does this do? And there we go. Ah. Oh, no worries. But at least we have something. We can see the numbers. Woohoo! So with in combination with the sprintf, but the only thing is that we are now limited until 2 numbers. But should be good enough for now. We can maybe do a calculation with how many digits we actually have, but should be fine for now. Soms my math is a bit off, but all right. Then we have the first part done. Then it basically means that we are able to see the score. Because just for testing sake, let's make bigger numbers. I don't think this is going to work now because it's now... Eh? Wait, I made a char array of 2 and we can see bigger numbers. All right, doesn't matter. At least we can have we can play Pong for quite a long time. Amazing. Cool. Very cool. All right, but now to do a proper animation, do a proper movement, I remember that we also need to have something like delta time. And the delta time, get time frame in seconds for the last drawn frame. Ah, perfect. There is already something for delta frame. Yeah, because for people that doesn't know it from the software development, from game development perspective, it's basically you want to have the time between the frames, and then that way we are when we are moving a specific object, then we always multiply it based on that delta time. So then it's if, for example, if the frame rate drops, then everything will still move on the same speed, basically. So let's... Watch out for that. Sorry, what do you mean with the extreme large numbers? Okay. Let's... we have the ball, and let's move the ball based on a specific speed. So we have position, but I think I forgot that we also need to have something like a movement velocity or something. So factor to velocity. This will be for the direction. I can see the code because my internet, but maybe it was because of that. Ah, okay. No, I was just trying because I got a char with a buffer of 2. and I was still able to write 3 digits for some reason. So that was, in my regard, that was actually kind of interesting. All right. But we have the ball.velocity.x is, let's make it for now like 45. And let's also do 45 on the other direction. Then what we want to do is we want to update the ball dot velocity plus delta is the no, not on the velocity, but on the bounce dot x. Then we do an with the plus on the ball dot velocity multiply here 1 delta, and this should be good enough. And then we should also calculate it for the I position. All right, should be good now. Then I think now the ball should move. Yes, but it will be a very boring Pong if it's going to go in that specific speed. So let's make it a bit quicker. Let's do something like 90. Is this better? Ah, it's still boring speed. Let's make it do it like 140. Is this better? Yeah. Still quite slow, but at least now for testing purposes, it will be fine. All right. So what does this mean? We want to have the if the ball dot bounce dot the I position is lower than 0, then the ball dot velocity is multiplied by -1, which indeed means that we're going to go into a negative direction, and the same thing for the I. And we're doing the same thing for if the ball is higher than minus 32, because the ball is 64. So we need to go with 64. All right. Then at the same time, we want to check if the ball dot bounce dot is lower than 0. Then that basically means that player to the right has won. Then what we want to do is we want to reset the ball wait. Yeah, normally I should make a function, but can I access a function? Yes, let's make it a little bit neater. Let's make a function. Or nah, just let's be lazy. Just write it all down. Why not? And the velocity is this initial set. Okay. Then we also want to have the ball dot bounce dot x is not and I think you might be worded. Okay, you convinced me. Let's spoken like a true C coder. Yes, I completely agree. let's make a function. Ball reset ball. Or can we just do a void and we can make a pointer? So that will be then ball. No, it's like this, I think. Types missing. Ball. Yeah, that should be it. Ball. So this is basically what we want to do. Then we can say here, reset ball, like this. Okay. I think this is going to be correct. At least now we have an easy way to reset the ball without duplicating any code, which is actually kind of nice. I completely agree. And if it's higher than 800 minus 64, wait, no. If it's completely out of screen, then we are going to reset it. And if it's higher than this, yes, because otherwise it will only hit on the side, and then you are automatically lost. So I think it's better if it's completely going out of the viewport, which in my opinion makes more sense. And then the pedal, which kind of the player, I know, but the score is 1, and otherwise we are adding score on the other one. All right. So now we have bounce check. So now we should be able to detect if the ball is out of range. Should this work? No. And I made an oopsie. Error expected before the end token. No, I don't think this is going to work because we want to have it as a reference. This is... I don't think this is correct. No. Because we want to have it as a reference. Then here we are left side of the memory doesn't have... Yes. All right. How do we doing a ref on the in C? Ref C. Ref C programming. Yeah, I'm reference struct C programming pass struct by reference. Some struct, yes. Okay. Oh, like that. Yeah. So it's like this. And then we can, aha. That's indeed exactly what I wanted to see. Then let's see. Yes. Ah, yeah. There you go. Then we are assigning in here. And now this part is probably also wrong. And this is also wrong. Now it should be fine. Are we now setting the ball on the correct? Yes. But it's okay. This is an oopsie on my side because the yeah, well, it doesn't make sense to also multiply the value of the I position. So of the X position, I mean. Otherwise, it will just bounce back, which doesn't make sense. Only with the I, it should make sense. So there you go. Voila. The basic Pong is er. The only thing is that we are not able to move the pedals yet. So now we need to make proper collision detection on the pedal side. Oh, it's we almost have a working Pong, guys. Almost. Then maybe we let me see what the current time is. It's maybe we can also add some sounds if that's possible. Yes. Oh. Now we are getting somewhere. So first thing that we need to do is we need to move the pedals. So let's first do something very easy. Let's just, when I am pressing the up and down, let's move both of them at the same time. So we can easily just test them. So, or, no. Okay, let's, if, what's the cheat sheet for keyboard? Keyboard is key pressed. Yes. Is key. Is, oh no, key down. I think my plan is that I will really like to have it done by an algorithm. So basically, we are going to move it just slowly against the direction of the actual pedal. Just very simple. Then that will be the next part when we have the actual collisions working. But for now, I just going to implement that they are both based on the arrows that I'm pressing. They will both move at the same time for now, temporary for now. Dot 0 dot bounce dot x -1 minus what should be a correct speed. Let's move it like on 150 or something, and then multiplied by the delta time. And we only are allowed to move if the pedal dot I is higher than 0. Of course. We can also just combine this in the same if statement, by the way, which makes it a little bit neater. All right. And then we also, and I said that we're also going to move the other one at the same time. Yes, I'm not checking the other one because yeah, this is just temporary code for testing. All right. Then we are going to add on the plus, and we want to have it on it's by the way not on the X, you idiot. It's on the I. On the I. Otherwise we're moving left and right. That doesn't make sense. Will be very interesting Pong otherwise. And we are having a height of 600 and our pedal height is 128. Yes, there's a lot of hard-coded code, but like I already mentioned, it's not going to be the prettiest code for now. I'm just trying to finish this within the stream with a working Pong demo. All right. Then we also want to move it by 0. There you go. Plus, minus, minus. Yes. Are we now able to move the pedal? Yes, we can. And it also stops, but it's the only problem is that it's horribly slow. In almost at a certain way that it's not playable, and maybe it will be better if you are pressing it longer that it has some momentum. But for now, let's keep it simple. Yeah, this is way better. So now we are able to move the pedals, and now we are just need to check the collision on both sides. And then we are bouncing back to the other direction. And also, if we are just going to simply do a minus or a negative on the value, then it will always go into a 45-degree angle. So I think maybe it will be more interesting based on the position where the pedal, where it hits on the pedal. That will depend on the bit on the rotation of the pedal, and that's something that I really like to try. If we can do that, of course we can do that. But I know that Raylib has a nice function to check for the collisions. Yes, check collision rects, and that's also the reason why I really like to use the rects, because then the collision is surprisingly easy. If the check collision rect and then ball dot bounce and pedal dot bounce, or yes, yes, we need to do it separate because we need to know on which one it's hitting. So let's first make it simple. Let's do it on the X, and then we're just doing the negative. And then the next thing that we're going to try is how are we going to that we can change the pedal based on where it basically lands, and then we can change the direction a bit, which will be makes it a bit more challenging and a little bit more a little bit more interesting. Otherwise, it will be a very boring version of Pong. So we are. So yes, I'm copy pasting this, but we are also having separate logic. We can make a function that we are having a reference and the reference of the ball. Then we can make the same logic. It should be fine. And then we can just calculate from the center position. No, yeah, I need to think how we are able to do that. All right. Anyway, because I also need to figure out if there are some nice functions to calculate to get the normal of the vector. All right, but I'm now rambling too much. Let's first see some things in action. Are we able to? Yeah, we have something. Oh, what's happening? I think the ball offset of the left ball is not correct. Let's make it for the testing purposes a bit easier, because now we are moving always to the other direction. Now we're going to always go to the other direction, which makes more sense. But we clearly can see that it's, yeah, there's definitely something wrong. And I think, of course, it's minus 64, you idiot. So now, yeah, there you go. So, and also let's double check if it's on the other side going correctly. Yes. All right. You see, we have a very boring, basic version of the Pong C edition. Yeah. But like I already mentioned, maybe we should increase the ball speed a bit, because this is a bit slow, in my opinion. All right. Maybe we can also add something. Whoa, 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 whoa. Yeah, this is way better. But you don't have time to think. There you go. Now we are getting somewhere. I'm completely agreeing, because this is yeah, Pong for people that don't. Well, they are a lot of time they are saying that Pong is written in uppercase, right? So it's kind of make sense in that regard. But we have Pong, guys. We have a very limited version of the. Oh, that's a very good point. We can increase the speed indeed a little bit, because we have the reference, so we can. So what we can actually, that is very easy to implement. You know that, because the when we are resetting the ball also from in the entry place, we can say that the ball dot velocity dot x is, let's say, we're starting with 240. And then we are, oh no, I'm no, because we should, when we are resetting, then we should reset back to the same speed. But when we are hitting the ball, when you hit the ball, then we can ball dot bounce. Let's yes. So that basically means let's not reset the ball velocity here. Let's just put it in here back. And the reason behind it is that because we want to do a multiply on the ball velocity. So in here, we can just say, let's, when we adding the score, then we are multiplying it with a small, not with 240, because that will be crazy. But we can do for something like 0.05, a minor speed bump. Then it will increasing exponentially. I think that makes sense. So there you go. Let's make the increment, I mean the multiply now a bit extremer. Let's see. Do I see a speed increment? Not really. Do I still reset the velocity? No. Oh, wait. Of course. Sometimes math is difficult. Let's do it like 2. 2. And 2. And 2. So now is the... Oh, wait. I'm resetting when the... let's see. Of course. Yeah. Well, I am setting it on the wrong direction. Reset ball. Yes. And here also we are resetting the ball. All right. So now we can set it to 1 point. What should we do? 1.2f. Something like that. I don't know. This is something that I know from C#, that you can put an F on the end for floating values, but I don't know if that's also the same in C#. Whoa. Now I did break something. What did I break? Reset ball. Oh. It's higher or lower, and then... Oh. Wait. I'm resetting the ball here. That doesn't make sense. Yeah, it's starting to be going to be a bit late, so it's going to be more and more and more a challenge for me. This should be fine. This should be fine. And also we want to set the... Yes, I'm reverting this back. All right. Oh, there you go. Yes. Reset ball. Yes, this is correct. Then this is correct. The score. All right. Let's see. Is it now? No, it's fine. But you can see it's going faster and faster and faster. And well, yeah, it's balancing is another degree of level. All right. See you. Thank you for coming by. All right. This part is now working. But do we have something for getting the normal? No. Thank you. All right. Next challenge. We need to somehow calculate the X and the Y position based on the position that basically that it hits. And there is no real way that we can calculate easily the normalized value. So, and normally I am using a helper function, so I don't exactly know from my head how to calculate the normal. Because like I already mentioned, I normally use a helper function, so to make things easier. All right. But that will not stop us. We can do it maybe with a simpler approach. So in here, we are detecting when the ball hits, and we need to do it the other way around. We also want to set the eye position somehow. And then we want to have it in a 45, well, the current, we want to have it based on the speed of the X, then divided by, yeah, that's going to be a very interesting one. So in here, we doing a ball dot, first we need to know the offset. So it's the float with the offset is the ball dot bounce dot the eye position. Yes, that's correct. Then based, okay, let's do something something interesting first. Let's do the wait, we can, by the way, we can calculate it because there is also something like an angle function, degrees. There you go. Degrees. Rotation. I also know that they have a mat function, but I don't know if it's been included or not. Core mat structs ray mat. Yes. Is this? Yes. So we do have a normalized value, which is perfect. But we also want to remap vector 1, vector 2, 0. Vector 2 angle. That's the one that we want. So because the ball dot bounce dot, okay, we need to make a vector first. So the offset vector is and also we also get the length. It's also perfect. Okay. Then I probably know how to deal with this. Then we're going to do offset. Then we're going to make a new a vector 2 with it's a vector 2, by the way, vector 2, and then we want to have it as 100. Is this not correct, or do we need to set it like this? Oh yeah, you need to set it like this. Okay, perfect. Because we want to know the offset vector, because then we know the rotation of X minus the ball dot, no, the pedal dot 0 dot bounce dot x. Yes, then we have the offset for the x position. And we also want to know it from the I position. I and I, but we also need to make sure that we are getting it from the center. So that means that we know that the ball is the 64 by 64, and the other one, the pedal dot x is dot plus 8, and the other one is, yeah, this is yet again 32, and the other one dot I is dot the pedal size is 128. So now we are really calculated from the center position to the center position. So then we know the direction where it basically lands, and then we are basically based on the middle position. Then we are shooting it back on that specific direction. Should be good. It could be that we are maybe want to cheat a little bit on that regard, because we maybe want to go a little bit more to the left. This is pedal 0. So that means that we are going maybe just like minus 64. Just then it will be way there, and then it the line between the pedal and the ball will be a little bit further. All right, then we have the rotation, and then we are getting the float rotation is vector to angle. Wait, this is not a function. Vector to subtract. Yeah, it's a function. But why is this then now an issue? And standard lib raymat, and it's now whining about that this is now an. Is that because of that I loaded in raymat? Yeah. But if I am now loading it back in, oh, that's an issue. Okay. Then we go for the okay. Velocity.x is yes. Yes. Okay, this should be correct. Then we are putting it in here. And then we are multiplying it by x. Okay. Ooh. Now I did break something. Expression expected before struct. Okay, I'm just going to do this a little bit. Just more the raw way. Is this correct? Yes. Okay, then we can just calculate it based on the I and the X. And the X. There you go. And that should be good enough. Then here we are doing it the same way. Yes, probably I should make a function out of it, but no, not this time. Yeah, this should be better now. Yes. Ooh. It does work. You see? Oh, no. Oh. Yes, probably I already found an issue because, yeah, if it's... Oh, that's an interesting issue. Check collision rect. Oh, yes. So probably what we want to do here is as well, it's a bit cheating, but because the ball gets stuck when you just enter it. So what we can do to prevent this is we are just making sure that the ball dot height is higher than let's say 15. Or just make it a bit more safe, 14. And in this case, for the other way around, is that making sense? No, it's let's make it 30. And for the other way around, we are making it it's 800, so that means that we are doing it 800 minus 30. No, not 38. Let's do 28 or something. And then here we are also doing higher than 28. So, all right. Very cool. Mm, um, okay, let's fine tune this a bit. This is still not correct. Um, let's, if it's higher than this and 10. Okay, just sometimes we did. Oh yeah, there you go. And now if you, it's still doing that part. So it should be fine if we are. And now if we, it's still, that's strange. Wait, why is it still doing that? Because if the ball at the pedal on the left is there. Oh, idiot, you need to use the ball, not the pedal. All right. It was 32, 30, and my original thought was also 30 here. So this should now be fine. Yes. And, oh. No, it's still broken on the other side. So let's put this one to 25, 25. All right. That part is still works. And let's see if I am able, to do it like, no, it's still doing that. That's interesting. So, yes. Ball dot bounce, correct. Yes, this is correct. This is also correct. Yeah, but this should be, if it's higher than 30, then it should be, because the upper bounce of the width is in total 32, so it should be fine. Yes. And now, no. Okay. Yeah. What we also can do, if you're just able to hit it, then we can also just say that we are going to say that we want to validate if it's already been hit. And then if it's already been hit, then we're going to ignore it or not. I think that makes more sense. So we are making ball pedal hit 1 is false. And then we can also just put this one into the struct. So ball pedal hit. Yes. So now what we can do is in here, we can just say we want to pedal 1 dot pedal hit is true. And if this is not the case, then we're going to say it's false. But we also can just do a double check, because and I will explain why. Because in here, all right, because now we are checking it double, but there is a good reason for it, because we only want to set this to false when it actually is not hitting anymore. And here we want to ignore it when the pedal is not hitting, when this flag is. And this is basically like a very simple in PLC or Arduino terms, like a rising flag, a rising edge. So basically, we only triggering when it's going from false to true. So this should be solving it. Okay, and now we are still able to hit it. Then now if we are, you see, and now we are still able to, you see now it doesn't happen anymore. Nice. So that's the basic version is now in that regard working. Woohoo! We have almost a working version, and I still see that we have time left. So what we now can do, we can now try to add some sounds to it, because I also prepared some sounds here. Let's add those in. Sure, add. So we have a fail, a hit, and a score. Oh, by the way, we are still moving at the same. That's right. When we are doing an up and a down, I completely forgot. I promised to make an. So the other one is not. Is moving based on the. What we can do is we can make a duplicate of this, and then we are only setting the other one, and we checking the other one. And what we are going to do is when this one, yes, let's do a calculation. The question is if I am going to do it the correct way around, but should be fine, I think. Ball dot I, and then if it's if the pedal dot I minus the ball dot, then it means that it's higher, so it needs to, and then we need to know if it's lower. And in this case, we want to move it this way. And this should now automatically move the other pedal. It should now work. Or it's the other way around. Also fine. You see, now we have an but yeah, it's going to be a bit quick. Okay, the speed ramp up is going very quick now. So now we are. Oh, it's also because I because I forgot. All right. I only want to move when the velocity, when the ball dot velocity dot it's the x, yes, it's the x, is higher than 0. Because now we're only going to move the pedal. You see, now it's going to that's still a very difficult enemy. Because, yeah, it's almost playing it perfectly. So probably I'm also making the other one a bit slower. Yes. Woohoo! We have the enemy. And let the other one win. All right. That's good. Oh, it also works. Amazing. So we have now, in theory, a basic Pong working. But, like I already mentioned, I also really like to add some sounds. So let's see how we can add sound. Sounds. This is the Raymat, by the way. Sound. Struct sound. Sound. It should be easy as sound. Then we have fill sound is load sound. Fill, no, it's just fill.wave. All right, very cool. Then we have the hit sound, which is hits. And we also want to do the score sound. And of course, we want to do an actual cleanup of unload sounds, fill sounds, hit sounds, and also unload sound, score sound. So now we have the 3 sounds. Should be, I think the sound should be hit, fill, score. Yeah, should be, is correct. I do have the audio enabled in the stream, so you should also be able to hear something. If not, then please let me know. But when we have a hit, so that basically means if it's out of bounds, then we're going to say here play sound, and that's then the hit sound. All right. When this is the case, then also going to say hit sound. Yes. When we place, then when we are, now I'm thinking of it, why do we have a fill sound? When it's going out of the boundary, then yeah, well, it's always fine. Let's do a score sound. There you go, there you go. All right, Then now we should have audio. No. Fail to get frame count for the buffer conversion. Fail to create buffer. Is there something wrong with the audio of those? I can remember there was something with it. Open. Let's open in Explorer. Let's see resources. Because this sound, show more options. I probably need Outer City for this. Skip. Okay. What's up with this audio? Fail. Ah, yes. I can remember indeed something with that this is split stereo track to mono. Then we also want to format this to 24-bit PCM. Should be more than enough. The fill and then and then export as wave. Fill dot, and then we need to go to here. Fill. Okay, save. Yes. Okay. Then we also have the hit one. So probably the same issue. Yes. Format 24 PCM. And we also want to split the stereo track to mono. All right. Mono for 44-bit. Yes, that's all fine. File, export as wave. And this is a hit. Yes, that's correct. Yes. Perfect. And then we also want to do the score. And this is already a mono, but still in the wrong format. File, export as wave. Score.wave. Yes. Okay. Nope. Okay. Let's see if it's now able. It's failed to get the frame count for the format conversion. Okay. Then now it's time to search stop, because now I'm a bit confused why it's not able to load it. Something about... Oh! Idiot. I first need to do the init sound. Yes. Yes. So we have now sound. Very cool. That's... Very good. And let's use for the when we're hitting the we have here the hit sound, and here we using the fail sound. Let's make some different sounds. I'm not a sound engineer, by the way. Yeah, that's going to be a bit annoying. Okay, I think no sound for that one. Should be fine. All right. Then the last thing, what I really like to add is a line in the middle. So let's do a draw a rectangle with position of, that's 400.0, and then the height is 2. Oh, 2. And the height is, let's see, we have 400 and the height is 600. And the color is gray. Yes. All right. Well, actually, to make it a bit more interesting, let's do a for loop. Then let's make it like, because we have a height of 20, so we are going to do it in 60. And then we can make actual dashed lines. Or or is Raylib already having something for this? Draw line dashed. Really? Ray, I don't have to almost write anything. If you are making all the fun stuff already there. Huh. Cool. But I need to use a vector. So it's 400.0. Oh. Yes, probably it's better to make a const out of this, but do we really care? No. So we are going to add here like the height, total height is 600, so that should be fine. Then the dash size is, let's do 10, space size is 10, and then the color is gray. This should be good. X is yes, and I want to have it as a double line, so I'm going to do it twice, but with a small offset. And now we should see a line in the middle. And we are drawing the ball and the texture first, so it should be fine. Too few arguments for draw line test. Okay. So we have the start, the end. Space size, gray. Start, end, size, space, and the color. Should be fine. Factor 2. Oh. Start line boss is no, that's not correct. 400.0. This should be correct. And then for the end line boss, we want to have it on 600. I think. Yes, we want to have it on 600. So it's the end line boss. I must say that I am still fighting a bit on the C part sometimes, but I can also see why some people are loving this. All right. So, sure, make it a const. Then I can also move it outside the loop, because this doesn't make any sense to put this in the while loop. All right. So, should now be correct. Yes, but also what I want to mention is that I want to have a double line. So I'm going to make a second one, and I'm going to do it the lazy way. So in here we are moving it with an offset of 1 and 2, and then we are copy and pasting this to 1 and 2, and 1 and 2. Oh. So we have a little bit thicker line. Yeah. Good. Oh, that's not good. Wait. Didn't I fix that part? Sorry for the sound, by the way. And also, to give it the final touch, we are not going to say hello Raylib. No, 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 no. We're going to say Pong live. There you go. And voila, my horrible version of Pong. Am I happy? I am. But we did it. And also that means that this will be the end of this live stream. Like I already mentioned, is that I am so happy for that we have reached the 100 subscribers. And oh man, the previous year was such an it was quite an interesting road. I must say that I have been switching quite a lot with in my content and such, also as my personality. But I just wanted to say that this year I'm really going to focus more on the actual implementations and more, and on the game projects, and also based on the Raylib community, there is a real big question for C# expertise in combination with Raylib. So I'm probably going to write some documentation for this. So I hope that you have enjoyed this stream, and then I will say up to the next, hopefully 500 subs. I mean, let's put the ball high, right? No pun intended. All right, I will see you the next time. Bye.